This time, I'll talk about AI and your career. Who is really at risk and what the data says. AI is advancing so fast. Many people are saying AI are replacing many jobs, but most existing measures rely on theory, what AI could do, not what it does. This model bridges the gap using real usage data. The main idea of my model is based on this paper, Labor Market Impacts of AI, a New Measure and Early Evidence. Now, let's take a look at this paper. This is a paper which is published on March 5th, 2026. So this paper is pretty new. And they have all the data analysis. And I reproduce some of the analysis in this paper and add more of my analysis. This paper can be downloaded over the internet, so if you want to read the paper, you can download it, read by yourself. What is the core problem with existing measures? Traditional exposure metrics ask, can an LLM theoretically speed up this task? They ignore whether AI is actually being used for those tasks in the real world. For example, authorizing drug refills is theoretically 100% LLM feasible, but not observed in practice. So, there is a massive overestimate of near-term displacement risk. In this model, I introduced a new metric combining 3 data sources. They are all public and available to download. Tasks are weighted by work context, automation versus augmentation, and the share of the overall role. I got a grounded, real-world measure of AI displacement risk per occupation. Now, let's run our model to check it out. This is my model built in Python. I will upload this source code to my GitHub so you can download it and check it out by yourself. Now, let's run our model. The first tab is Career Explorer. You can see there are many occupations in the drop-down list. If we choose the first one, computer programmers, click Analyze, and you can see here, theoretically, the coverage should be about 94%, but currently we see 74.5%, so still like 19.5 pp gap here. And if you break it down further, the AI coverage for system design is about 18%. But if you go to the coding and debugging, it is 82%. So you can see it's more difficult to use AI to do the system design than coding and debugging. I think over time, most of the work of coding, debugging will be replaced by AI instead of using human. Now, let's pick up lawyers and click Analyze. You see the coverage supposed to go to 60%, but currently we see like 35%. And for the court representation, you see maybe the AI coverage is 5%. You can imagine if you go to court, maybe it's better a human lawyer instead of using AI. But if you go to the legal research, like over 50% will be covered by the AI. And if you take another occupation, cashier, maybe you think this is pretty simple task if you say analysis. And surprisingly, only 30% theoretically will be covered by AI. And now it's only 5% observed exposure. This is quite interesting. So you can click around with all those occupations, check the numbers, and because my model is based on the real world data, so it's not based on the like imagination. So you can check out all those numbers. And also here, for example, if we choose computer programmer again, you see the wage level is pretty high. It's 70 over 100. And so this side, if you close to 100, is best, right? It's good side. This one is like worst side. 0 means the worst. You see the AI exposure is pretty high. And if you choose cashier, you can see here the AI exposure is kind of low, so it's pretty good. But the wage level is not that good, because everybody knows if you work as a cashier, you definitely will make less money than programmer. So you can use this tab to understand your own field or explore alternatives before making career decisions. Now, if you go to the second tab, compare occupation, you can see I have all those AI exposure ranking by the occupation. This is third tab, DID unemployment model. You can see here there is a big jump here, and basically this is caused by COVID pandemic around 2020, and after that it's back to normal. So you can see the exposure like here and here. The unemployment rate remain almost the same. That is saying, so the difference in differences estimate is effectively 0, confirming the paper's main finding that no measurable unemployment impact has emerged yet among highly exposed workers. And there is another chart here. The second chart shows the impact for young worker hiring. So among the age from 22 to 25. You can see still here is because the COVID pandemic, and you can see for the most exposed occupation, from this starting rate deep to here, and for the non-exposure occupation remain almost flat. So that is saying there were roughly 14% slowdown in job start rates in exposed occupations, offers the first tentative signal of AI's effect on hiring. So what it says is AI has much bigger impact for young workers. Now, if we go to the fourth tab, on this tab, you can see AI exposure are projected to grow more slowly using BLS employment forecast through 2034. The scatter plot and regression line show a modest but negative relationship. Every 10% point increase in AI coverage is associated with roughly a 0.6 percentage point drop in projected job growth. If we take a look at this residual table, the occupations are outperforming or underperforming that trend. If we take a look at this information security analysts, you can see the exposure is pretty high, 48.6%, but actual growth is 33%, and the residual is about 28. So if we take a look at the graph, information security analyst is here. So exposure is pretty high, but projected employment change is here, so still in high demand. Now, if we go to the next tab, this shows worker characteristics, and the blue bar shows no exposure, and this red bar shows top quantile. You can see Hispanic somehow has a lot of no exposure, and if you come to here, most affected degree is bachelor's. You see, it's pretty high. Okay, now let's summarize what we found from this model. We just saw the results from a model. Theoretical AI capability covers up to 94% of computer and math tasks. Observed actual usage covers only 33% of the same category. Across all occupations, actual coverage is a small fraction of what's theoretically possible. So, what kind of conclusion we can reach from this? The gap is closing. Tracking it is the early warning system. Which jobs are most exposed? We saw like computer programmers, customer service representatives, and all the following jobs are very risky. And 30% of workers had zero coverage, like cooks, mechanics, bartenders, lifeguards. And high exposure is not equivalent to high salary risk. That means it cuts across wage levels. So who is most at risk? Look like female, better educated, higher paid, and older people. This is not a low-skill displacement story. White-collar, educated, well-paid workers face the greatest theoretical risk. On the tab about AI exposure and job growth projections, we can see like every 10% points increase in observed exposure, and the growth projection drops about 0.6 pp. The interesting thing, just like I mentioned, information security analysts, although they have 49% exposure, but still 33% projected growth. And for the electricians, only 8% exposure and has 11% projected growth. With the DID model, you can see ChatGPT launched in November 2022, and there's no measurable unemployment impact from AI so far. But as I mentioned before, there is an early warning signal for young workers. 6 to 16% employment drop for workers aged from 22 to 25 in exposed roles. And this effect is specific to workers aged from 22 to 25, not seen in workers over 25. Therefore, AI is slowing the door in, not pushing experienced workers out. In my model, I use a composite score built from 3 components. 40% from AI exposure risk, and if it's lower exposure, it will have better score. Then BRS projected job growth, they take weight 35%, so higher growth will have a better score. And the wage level take weight 25%. Of course, higher wage will have a better score. And you can see, as I mentioned before, information security analyst is quite interesting, has a strong outlook, although have a low medium exposure, and data entry keyers has a very high risk. Registered nurses have 14% exposure, but needs to perform strong physical and interpersonal tasks, so it is resilient. So in my model, I use Python as a programming language and Gradle as the graphics user interface, and you can install required package and run it on your local machine. And all the output are auto-saved as JSON and CSV, so you can analyze the data later after you run the model. So, what can we learn from the results of my model? AI capability and AI deployment are very different things. The gap is large and matters. No unemployment crisis yet, but early hiring signals for young workers are worth watching. Surprisingly, the workers most vulnerable to AI disruption are often college-educated, higher-paid women, not low-wage laborers. Observed exposure is a better predictor of labor market outcomes than theoretical scores alone. Because I'm using the actual data for this model, so the results might change over time. What should we watch next? So, how fast does the theoretical to observed gap close across occupational categories? Then we should think, will the young worker hiring slowdown spread to older workers over time? How are recent graduates with AI-exposed credentials navigating the job market? And which occupations move from augmentation to automation use patterns? And all the data I'm using, you can get it from this Hugging Face website. These are the references I use for my model, and if you do your own analysis, you can go to my GitHub and download my model source code and use the data to do some analysis by yourself. This is the topic I want to talk about today. AI and your career. Who's really at risk and what the data says? Please comment, like, and subscribe to my YouTube channel. Thank you for watching.